Okay, today we're going to do right triangle trigonometry. This is section 11.1. Let's get started. Today we're going to talk about the word trigonometry and what it means. Trigonometry is a Greek word, and we can break that into its pieces. We have the beginning of this, or the prefix. We've got trigonon, which means triangle, and then we've got metron, which means measure. So this is the measure of triangle, or it's the way to measure the pieces of the triangles. And that's what we're going to study today. Trigonometry has many uses. We can use this for building. We can use it for surveying, building roads or finding surveys of where you want to build buildings and so forth. We can use it in space travel. We can use it in navigation, which doesn't just limit itself to submarines and boats, but that could be navigation as in like the global positioning satellites or GPS. It also can be used in physics, which covers a wide range of topics. Now we're going to actually talk about the trigonometric ratios. Sine, cosine, tangent. That's the abbreviations for the first ones over here. Then we've got cosecant, secant, and cotangent. We're going to give each one of these sides of the triangle and angles of the triangle, we're going to give those letters. So we're going to give A, start with A, we're going to go B, and then we're going to use C. And this one is your right angle. These sides of the triangle are your legs. And this last one, the opposite of the right angle here, is called the hypotenuse. We're going to use this letter A, and the opposite of the letter A is going to be lowercase a. And the opposite of that side B is going to be lowercase b. And the opposite of the hypotenuse is going to be lowercase c. Now we're going to learn these trigonometric ratios here. Trigonometric ratios for sine, cosine, and tangent will fall under the acronym of SOHCAHTOA. And the SOHCAHTOA are the abbreviations for these ratios of the sides. So if I was to divide the opposite and the hypotenuse, I would get the sine of A. So if we have our ratios on here, we have sine of A. The sine of A is right here, the angle. Opposite over hypotenuse will be A. That's the opposite side. And the hypotenuse is always that letter C. The next one is the ratio of cosine. Cosine here, we have the abbreviation CA, which is for CAH. Just like sine was for the SOA was SOH. Let's do cosine here. It's the adjacent of A over the hypotenuse. We have A, and the adjacent side is the one right next to it, not the opposite one, which is B. And the hypotenuse is C. When we say the word adjacent, we mean the adjacent leg, because the hypotenuse would be technically next door. And now let's do our tangent. Tangent of A is opposite over adjacent. That's where we get the TOA from. A, the opposite of A, is little a, and the adjacent to A is B. So we have A over B. There is one other thing you need to realize. If I took the measures of sine A and divided it by the cosine A, I would also get tangent. Let's now do all of the ratios for cosecant, secant, and cotangent. The wonderful thing about this is that I want you to notice the relationship between these. They are just the reciprocal. Just like a moment ago when we found the opposite of the hypotenuse to be A is the opposite and C of the hypotenuse of A over C. We take the reciprocal, which will be the hypotenuse over the opposite, which is C over A. The cosine A was the adjacent over the hypotenuse, which was B over C. And the secant is the reciprocal of that, C over B. The tangent, which is the opposite over adjacent, opposite A over the adjacent B, and the cotangent is the reciprocal, B over A. Now that we have done these, let's use them on some other triangles. We're going to use these on some special triangles. We're going to use these on a 30, 60, 90 triangle first. The 30, 60, 90, here's the 90 part, the 60's up here, and the 30's over here. The ratios for a 30, 60, 90 triangle work out like this. If I have any number, and I know that, and it's the opposite of that 30, if I double that, I will get the hypotenuse. If I take that value and I multiply it by the square root of 3, I will have the opposite, the 60. This next special triangle is a 45, 45, 90 triangle. The wonderful thing about a 45, 45, 90 triangle is that these two are the same value because they're isosceles. And if I use the Pythagorean Theorem, I would get this one to be A times the square root of 2. We can use this to find all of these ratios in here. In your note sheets, you have one extra column right here that we will do later. We will do that one later. So if I'm going to do the 30-degree angle, that one is right here. So the sine was the opposite over the hypotenuse, which is A over 2A. A over 2A reduces to just 1/2. I am suggesting that you just write the 1/2 in there. The cosine of 30. The cosine of 30 is the adjacent over the hypotenuse, which is A square root 3 over 2A. These A's reduce and leave me with square root 3 over 2. The tangent is the opposite over the adjacent. That was the 30 degrees. Opposite over adjacent, which is A over A square root 3. A over A square root 3. We're going to have to rationalize that denominator. And the A's reduce, leaving us with square root 3 over 3. Let's do the 45-degree angle, which is over here. The sine of that 45 is the opposite over the adjacent, which is A over A square root 2. My A's will cancel, and I'm going to rationalize the denominator and make it square root 2 over 2. The cosine of the 45 is the adjacent over the hypotenuse, which will again be A over the square root of 2, the same thing we have there. So our answer again will be square root 2 over 2. The tangent of the 45 will be the opposite over the adjacent, which will be A over A, which equals 1. Let's now do the 60-degree angle, which is over here. That 60-degree angle will be the opposite over the hypotenuse, which is a square root 3 over 2a. That will reduce to be square root 3 over 2. I want you to notice we got that right here. Let's do the cosine. The cosine of the 60 is the adjacent over the hypotenuse, which was a over 2a, which reduces to just 1/2, the same as we got right here. And last, the tangent of the 60. The tangent will be the opposite over the adjacent, which is a square root 3 over a, which is just square root 3. I am suggesting that your chart has these values. How we got them isn't something you'll need to memorize. What they are is what you'll be most useful. Let's do some problems with this. Let's find the values of each, and we're going to round our answer to the nearest 10,000th. Now, before we do that, we're going to have to use your calculator here. In this picture here, I'm pointing to the mode button, and you're going to need to press that mode button. Before we can do this problems, you're going to have to make sure that you are in degrees. So you need to use your down arrow, scoot down, and then scoot over and highlight that degrees, and then hit enter so that it turns a dark shaded highlighted bold. And then use it to do these problems. What you're going to do is you're going to type in your calculator tan 85 and press enter. And on this one, you're going to type in sine 65 and hit enter. So pause this video, go and get your calculator out and type in tan 85 and push enter, and then do that same thing with sine, and let's compare our answers. For tangent 85, you should have gotten 11.4301. Remember, this is to the 10,000th, so you need 4 decimal places. Then for sine 65, you should have gotten 0.9063. Don't forget that you need to round at the end. Now, for secant, you should notice on your calculator that you only have 3 buttons: sine, cosine, and tangent. You do not have a secant, a cosecant, or a cotangent. Now, secant, if you remember, equaled 1 over cosine. That means it's a reciprocal of cosine. So to be able to evaluate it, you're going to have to, in your calculator, type 1 over cosine 26. And when you do, you should get 1.112. For cotangent is the reciprocal of tangent. And so you're going to have to type that in that direction, 1 over tangent 40. So go ahead and pause this video, type that in, and come back and let's do it together. You should have gotten 1.1918. All right, let's do some more. We're now going to use this with some triangles. We're going to find the value of the trig function indicated. We're going to do sine of theta. So we need to find the theta, which is this angle right here. We're going to take the sine of it. And if you remember, sine, which went with our SOHCAHTOA, was opposite over hypotenuse. So sine theta, the opposite is the 15, and the hypotenuse is always the one opposite the 90, which is 25. So we have 15 over 25. When we reduce that, we take 5 out of each. We're going to get 3 over 5. Let's do number 14. We're going to do the cosecant of theta. Our ratios were sine, cosine, and tangent. We have SOHCAHTOA. We have the ka and the toa. And the cosecant was the reciprocal of sine. Sine was opposite over hypotenuse. So the opposite is 8 over 10, which is the hypotenuse, but we need to take the reciprocal, which is 10 over 8. We're going to take 2 out of all of those, and we'll have 5 over 4. Let's do now number 19 and 20. This time, we don't have all the pieces. One of our pieces is missing. We might need that piece. Tangent was the opposite over adjacent, and we're talking about theta here. Theta is this angle here. The opposite over the adjacent, the opposite's here, is 4. But the adjacent, we don't have that one. We don't have this value over here, which is the adjacent. We're going to have to find it. We know this leg and this hypotenuse, but we don't know that one. We're going to call it x. So x squared plus 4 squared equals 2 square root 5 squared. X squared plus 16. When I square this, that means I square the 2, which becomes 4. And I square the square root of 5, which becomes 5. So 4 times 5 is 20. Subtract the 16 over, and I get 4. And x is going to be the square root of 4, which is 2. This value right here is 2. That's the adjacent that we were looking for. 4 over 2 reduces to 2. Let's do the secant. Secant is the reciprocal of cosine. Cosine was our ka, so katoa. So we need to do the reciprocal of that. Cosine was adjacent over hypotenuse, but secant is hypotenuse over adjacent. So the hypotenuse is 25. We have that one. But we don't have the adjacent. We're going to have to find it. We're going to call it x. 7 squared plus x squared equals 25 squared. We're using the Pythagorean Theorem. 7 squared plus x squared equals 625. And the 7 squared is 49. Subtract the 49 to the other side. X squared equals 576. Take the square root of both sides, pause this, put it into your calculator, and calculate the square root of 576 and come back when you have it. You should have gotten 24. So the value right here is 24. That is my adjacent. 25 over 24. I want to let you know that number 19 and 20 is like the ones above it, 17 and 18. So these are the examples for that. You can do even more. Let's go ahead. We're going to do numbers 25 and 26. This time they did not give you a triangle, so we're going to make one. The instructions say to find a value of the trig function indicated. You're looking for the cosecant theta, but they tell you what cosine equals. So let's draw our triangle. You get to choose if you want to put theta here or here. I usually choose to put it on the bottom. It tells us that cosine is square root 2 over 2, and cosine is the adjacent over the hypotenuse. The adjacent is square root 2, and the hypotenuse is 2. The cosecant theta is the reciprocal of sine. Sine was our SOHCAHTOA, here's our SO, is opposite and hypotenuse, so the Reciprocal will be hypotenuse over opposite. We need the opposite. We have the hypotenuse. So we're going to have to use the Pythagorean Theorem. We're going to have x squared plus square root 2 squared equals 2 squared. X squared plus 2 equals 4. Subtract that over and we'll get 2. X squared equals 2. Take the square root of both sides and we will get x equals the square root of 2. If I put that right in here, I need to rationalize that denominator. We'll have 2 radical 2 over 2. Reduce, we just have the square root of 2. That's the answer for number 25. Let's move over to number 26. Number 26, we're looking for secant theta. Secant theta is the reciprocal of cosine. Cosine had the ka part, which is the adjacent over hypotenuse. We need the reciprocal. They didn't give us a triangle. We have to make our own. They told us that the sine of theta, which I'm putting my theta there, is 4 over 5. Sine, for that's the part, is the opposite over the hypotenuse. The opposite is 4, and the hypotenuse is 5. So 4 and 5. We have the hypotenuse of 5, but we don't have the adjacent. We're going to have to do the Pythagorean Theorem. 4 squared plus x squared equals 5 squared. 4 squared is 16, and 5 squared is 25. Subtract the 16 over, and we get 9. The square root of 9 is 3. For those of you who have memorized it, this is a 3, 4, 5 triangle. If you would realize that you have a 3, 4, 5 triangle, this portion of the Pythagorean Theorem is taken out. You would not have to do it, because you would see the 4 and the 5 here and automatically jump to the 3 without doing all that work. So that adjacent was a value of 3. The answer is 5 over 3. Let's do number 21 and 22. The instructions say that in each triangle A, B, C, the angle C is a right angle. We're going to find the trig function indicated. We're going to find sine of A. They did not give us a triangle, but they gave us the pieces. If I put C there, which it tells us that angle C is the right angle, we can put A and B anywhere we want. But lowercase a is here, and lowercase b is here, because they're opposite their angle parts. They tell us that b is 9 and a is 12. So we can just substitute those right in. b is 9 and a is 12. We're looking for the sine of a. If you remember, sine is opposite over hypotenuse. And we're dealing with a. So the opposite for a is 12. But we don't have the hypotenuse. So we have 12 over, we don't have that one. We're going to have to do the Pythagorean Theorem. X squared equals because that's the hypotenuse. 12 squared plus 9 squared. X squared is 144 plus 81. 144 plus 81 is 225. Let's take the square root of both sides, and we get x equaling 15. So this x value here is 15, and that is our hypotenuse. We need to reduce this fraction. We can take a 3 out of both. 12 divided by 3 is 4, and 15 divided by 3 is 5. This was a 3, 4, 5 triangle. It had just been multiplied. If we would have realized that this 9 and 12 were just the 3, 4, 5 multiplied by 3, we could have figured out this one quick was 15. That's why knowing the 3, 4, 5 triangle is very valuable. Let's do number 22. We're looking for the cosecant. Cosecant is the reciprocal of sine. For sine, it's so. For the part of the SOHCAHTOA, so it's the reciprocal. It's the hypotenuse over the opposite. They didn't give us a triangle. We're going to have to make our own. They told us that C was at the right angle. We can put our A and B anywhere we want. But little a is opposite angle A. And lowercase b is opposite the angle B. We needed the hypotenuse and the opposite. The hypotenuse we don't know. We're going to have to find it. X squared is going to equal 8 squared plus 15 squared. That's going to be 64 plus 225. You can go ahead and pause that and put that in your calculator if you need to. X squared is going to equal 289. When we take the square root of that, we're going to get a nice number, 17. So this hypotenuse is 17. The cosecant is the reciprocal of sine. So we need the hypotenuse for the numerator, which is 17. And we need the opposite, which is 8. We have found our answer. Let's use this sine, cosine, and tangent to find more information. We're going to use it to find the measures of sides. You are asked to find the measure of each side indicated. You're going to round this to the nearest tenth. We're asked to find the measure of x. We need to evaluate it with an angle. The relationship with these two things that we know with this angle are, this is the opposite and this is the adjacent. So we need to look at our SOHCAHTOA. Which one is opposite and adjacent? Is it sine? Is it cosine? Or is it tangent? Opposite and adjacent are going to be tangent. So we will write tangent. We always write tangent with an angle. The opposite and the adjacent are 8.6 over x. Now we need to solve for x. We need to multiply those sides by x. We'll have x tangent 68 over 8.6. we're going to divide by tangent 68. So in our calculator, we will be typing in 8.6 divide tangent 68. Pause this, work it out in your calculator, and come back. So when I did it on my calculator, I got 3.5 because I only needed to one decimal place the 10th. Let's review what we did in this lesson. We learned the trig ratios, sine, cosine, tangent, and their reciprocals. We learned how to find them, and we learned how to use them. I hope this has been helpful. Goodbye.